Okay, so we're going to do an EOC review on quadratics and factoring. So remember that a quadratic equation is when the output is a function of some independent variable squared, right? So the variable, the highest exponent is squared. Okay, and that yields, that makes a parabola, whether it's concave up or concave down, right, is a factor of what the A term is, but I'll get to that more, right? But they have three important points, okay? The first point is the y-intercept, okay? The y-intercept is where the function crosses the y-axis and x is 0 at the y-intercept. Okay, so there's a form for that where you can just take the x-intercept right out of that form, and that's in standard form, where y equals a times x squared plus b times x plus c, some constant. Okay, x's are your variables, and a, b, and c are your different values. Okay, another important point is the vertex, my most favorite point on a parabola, and it is the maximum of a concave down parabola and the minimum of a concave up parabola. And that can be given to you in the form of equation in vertex form, which y equals a times the quantity of x minus h squared plus k. So this h is the x value of your vertex, and the k is the y value of your vertex. And recognize that h is negative, so this x value is negative, right? So it would be positive in the equation. Y is not opposite, so this is positive here, and that would be positive here. So, and then the other two are the x-intercepts. Okay, the x-intercepts can be given to you in y equals a times x minus q and x minus p, where p and q represent the lesser x and the greater x intercept. Doesn't matter which one is which. Recognize that negative means that it's opposite of what the sign is on the coordinate points. So these are negative x's. These would be positive x's in the equation. Okay, and when these is equal to 0, this is known as the zeros of the equation. And the product law, the zero product law, says that if this is 0 on the right, these are 0 on the left. So x equals q, let me do this the long way. So x minus q equals 0, and x minus p equals 0, so x equals q and x equals p, and that's why they're opposite in the equation. Okay, so let's focus on these two equations here. Okay, if I'm given the equation in standard form or a variation of standard form and I put it in standard form, right, I can factor this into this form and it'll give me the x-intercepts. Now I don't need to know y-intercept form if I recognize that the axis of symmetry is directly in between the two x-intercepts, right? So if I knew this distance and I divided it by 2 and then I added that distance onto here, it would give me the x value of my vertex. If I have the x value of my vertex, I can plug it in for x in this equation or this equation, and it'll give me the y value of my vertex, because that's how functions work. Okay, so factoring, first thing is first, make sure there's no greatest common factors in these things that you can factor out and make it easier on you, right? But there's two major types of factoring. Okay, one when a is equal to 0, and one when a is not equal to 0. And I'm going to show you an example of each, and a couple examples actually. So let's say I have x squared plus 10x plus 24 equals 0. I know that the y-intercept of this is 24, and my a term is positive. Remember, when A is positive, this is concave up. When A is negative, it's concave down. So A is positive, so this is going to go concave up, and the y-intercept is going to be at 24. That's all I know right now. So, like, I don't know if it's that y-intercept or it's that y-intercept. That's all I know. Okay, so I need to figure out how to factor this into its basic factored form. All right, so remember, we have this table. This is my B term sign, this is my C term sign, B and C term sign, and then the parenthetical pair as a result. Okay, so if I have a plus and a plus for my B and C, it results in a plus and a plus in my parentheses. If I have a minus and a plus, that's when it results in a minus and a minus in my parentheses. If I have a plus and a minus, or a minus and a minus, okay, that's plus or minus, and it doesn't matter which order they go in. Okay, so here my first step is to identify the parenthetical pair signs like this. That equals 0. That's a plus. That's a plus. So I have a plus and a plus on the inside. All right. Then I have an x and an x. That's why x's are pretty easy. I just got to drop the x's in. Now I need the factors of 24 that, when combined, make a 10. Okay, using these two signs. Right. So I have 24. So I have 1 and 24. That will make 25 because it's plus and plus. Right. I have 2 and 12. Right. That makes 14. If one was a plus and one was a minus, that might work, but this is a plus and a plus, so I can't use a minus sign here. I have a 3 and an 8. That makes 11. And then I have a 4 and a 6. That, when added together, makes 10. Right. So 4 and 6 equals 24, and they added together, they make 10. So this is 4 and 6. All right, so when x plus 4 equals 0, and x plus 6 equals 0, so x equals -4 and x equals -6. Right, so I can graph this thing pretty easily now, right, where it's going to be concave up, it's going to be at 4 and 6, so, or -4 and -6. The difference between, you can't see what I'm doing, the difference between -4 and -6 is 2, right? So I'm going to add 1 onto that because 2 divided by 1, or 2 divided by 2 is 1. Add on to this, so I started at -6. This is going to be at my axis of symmetry at x equals -5. So if I know the x is -5, I can plug it into here, and I'll get x, or -5 plus 4, and -5 plus 6, right? And when I combine all those, I'm going to get a -1 and a +1. So my y value is 1, -1. So right here, and that makes sense because this is supposed to be concave up with a y-intercept of 24, right? So that's where this came from at the very beginning, y-intercept of 24. And that would only work if this was concave up. Okay, that's not the best parabola. It's not very symmetrical, but you get the idea. Okay, now say, for instance, that I have a quadratic equation where my a coefficient is like 3, right? So I have a 3x squared. And then I have a plus 23x and a minus 36. Okay, and this equals 0. Whoops. And this equals 0. Okay, so I have to slide and divide this. That's, I think, is the easiest way. So this is the procedure for that. Right, first take this 3 and slide it out of the way, and rewrite this with one exception. All right, so x squared plus 293x. Instead of just copying down the -36, you take the thing you slid out of the way and multiply it by -36. So this is going to be -108. That equals 0. All right, so now I need the factors. Well, first let me go ahead and set up my parenthetical pair. Plus and a minus make a plus and a minus. So now and then I have an x and an x. So now I have a 108 that I need the factors of that'll make 23. So I have 1 and 108. That'll make 109 and 107. I have 2 and 54. That would make 56 and 52. I got 3 and 36, I think. 30 and 36. That makes 33 and 39. And I have 4 and 27. 4 times 27 is 108, and that will make a 23 if I start with 27 being positive. I need a positive 23, and I make my 4 negative. Okay, so there is my baseline factored form, but I'm not done yet. I got to take this 3 and divide each of those factors by 3. So this is one of 3 different scenarios. This is the best case scenario, right, where if I divide this by that, I get a whole number. So this is x plus 9. Okay, so you make the one that's going to be a whole number. The other one, you slide over here and make that coefficient of x, so it's x minus 4, right, and that's going to be equal to 0. Right, so I have x plus 9 equals 0, and x minus 3x minus 4 equals 0. So x equals negative 9, and x equals positive 4 over 3. Okay? And then you would find, if you want to find the vertex with this, you'd find the difference between, that's 1.5, or excuse me, 1 1/3, and negative 9, and then divide that by 2 and add it on to negative 9. That'd be the x value of your vertex. So I'm not going to do that because it's just for sake of time. Okay, so my x value is that. Okay. All right. So another scenario is, say, for instance, let me bring up the question. Okay, I found it. Say I have the question 6x squared minus x minus 2, and that equals 0. Okay, and I want to slide and divide this. Okay, so the first thing I'm going to do is slide the 6 out of the way. And I'm going to have x squared minus x, and now I have to multiply 6 times negative 2 to make negative 12. That equals 0. Okay, now I need my parenthetical pair based upon a or b and c's sign. That's going to be a minus and a plus, or a plus and a minus, it doesn't matter. Right, and x go here. Now I need the factors of 12. That will make negative 1. Okay, so my factors of 12, that'll make negative 1 is 4 and 3. I need 4 to be negative because I end up, if I add 3 to it, I end up with a negative 1. Now I divide both sides by, not both sides, by this equals 0, remember. I divide this by 6 and by 6. And here I have a situation where I do not have a whole number as a result. Okay, if that's the case, pick one to make into a fraction. Okay, I'm going to make 3/6 into a fraction because I like halves, right? Because 3 divided by 6 is a half. So x plus a half, right? And then I'm going to move this to the coefficient of x. It becomes 6x minus 4, and that equals 0. Now you may notice something. You may notice I could set this equal to 0, and I get x equals negative 1/2, and I get x equals 6/4, right? That was reduces down to 2/3. But this isn't completely factored, right? Because there is a common factor of 6 and 4, and that's going to be 2, right? So if I take this 2 out, right, I'm going to get 2 times 3x minus 2, and watch what happens when I take this 2 and I multiply it by that, right? I'm going to get, I took it out of this and I'm going to put it in that because they're all factors and they're all multiplied together. So it's going to be 2x plus 1. That equals 0. Okay, so the 2's went from out here and it went back into here. So 3x minus 2, 2x plus 1 equals 0. So I know that 3x minus 2 equals 0 and 2x plus 1 equals 0. So 3x equals 2, so x equals 2, 2/3, which 2 divided by 3 is 2/3. 4 divided by 6 is 2/3. It's opposite of negative, which is positive, right? And then I have negative 1 equals 2x, right? And then divide both sides by that, and I get x equals negative 1/2, right? So those are my two x-intercepts. And then, like I said, I could figure out the distance between these two, and then divide it by 2 and add it to my lesser, and that's going to give me my x-axis of my intercept. Plug that into here, I'll find the y-axis of my vertex, the x value of my vertex, and I'll find the x value of my y-intercept. Okay, so those are two different scenarios for that case. Okay, so there's some special cases. One special case is if I have a perfect square like 25x squared minus 16. Right, this is a perfect square and this is a perfect square, and they are separated by a minus sign. So it's this minus this. So the minus is the difference. So this is known as the difference of squares, because that's a perfect square and that's a perfect square. Okay, so when I have the difference of squares, I set up my parenthetical pair with a positive and a negative. Okay, then I take the square root of this term, the coefficient and the variable. So square root of 25 is 5, square root of x is x, and I put it here and I put it here. Okay, then I have negative 16, right? The square root of 16 is 4 and 4, and there I have my two factors, and these both, say for instance, equal 0. So I would have 5x plus 4 equals 0, and 5x minus 4 equals 0, in which case I'm going to have 5x equals negative 4, so x equals negative 4/5, right? And then I'm going to have 5x equals 4, so x equals 4/5. Okay, that means that the vertex is on the y-intercept. Okay, because it was on the y-axis. The vertex of this is y equals 0, right? Because these are equidistant from the x value of the vertex, right? The x value of the vertex is 0, so x equals 0. Okay. So that's pretty cool, because plus 0x. Okay, so now that's one way to do it. Okay, so another special case is, say I have a perfect square trinomial. That's 3 terms. We'll say we have, like, I don't know, 4x squared plus 6x. What would have to be here to make this a perfect square trinomial, meaning that the first term and the last term are perfect squares? I'm going to make this a negative. Okay, so I'm going to take this and divide it by 2. That's going to be equal to 3. I'm going to square that, and that goes right there. So my perfect square trinomial is 4x squared minus 6x plus 9. So if I know that's a perfect square, that's a perfect square, does not necessarily mean it's a perfect square trinomial. If I take half of the second term and then square it and get the third term, that is that's how it indicates to me it's a perfect square. Or I take square root of my third term and then multiply it by 2, and it's my second term, that gives me the correct answer. So when it's like this, it's going to be a binomial squared, where my first term is the square root of that, which is 2x, because the square root of 4 is 2, the square root of x squared is x. The sign of the second number, which is negative of your b term, and then the square root of your third number, right? So this is 2x minus 3 squared, which is 2x minus 3 times 2x minus 3, and so 2x minus 3 times 2x minus 3. Those are the same thing. Okay, so when I multiply the 2, right, I get 4x, right? Then I get negative 6x, and then a negative 6x plus 9. excuse me, make this positive, okay? So that's positive 6x, positive 6x. What did I do wrong? Let me pause this for a second. Okay, I know what I did wrong. So when I complete the square, you can only complete the square if that term is a, right? So this isn't going to work. So I made an error. Let me do another one. Okay, so I say I have x squared plus 6x plus 9. So this is a perfect square because this is 1. I forgot about that one. That is 1, right? So if I were to go to do this, right, this is going to be the square root of the first term, sine of the second term, square root of the third term, which is 3 squared, right? So this is going to be x plus 3 times x plus 3, right? And it's going to be x squared, 6x, 6x, 9. So that's going to be, 3x, 3x, and that's going to be 6x, okay? So that's the perfect square trinomial. So when you have this is a, this is 1, right? And this one is a perfect square. You can put it in the binomial squared. Even if it's not, if you think it might be, give that a go because that's really easy, and then see if it equals the same thing. Okay, because sometimes it will end up being the same. So look out for those perfect squares. Okay. So this case would be x equals plus or minus 3, right, for my x-intercepts. Okay. So that is that one. I hope it helped out. Sorry about that hiccup on the last one. Hope you guys understand it better.